Solutions can be classified as either electrolytes or non-electrolytes. And what that basically means, does it conduct electricity? So a solution is a ionic or a compound. For this purpose, we're going to talk about ionic compounds that are dissolved in water. Now those ions, when they dissolve in water, they're going to separate into individual ions, and when that happens, then that solution can actually conduct electricity. And when that occurs, we call that an electrolytic solution or an electrolyte. Now, some ionic compounds may not dissociate completely, where some of them kind of just break up into the ions a little bit, but mostly stay together. Now, that is what we would call a weak electrolyte. Now, if a solution doesn't break, if you have solutes that don't break apart into ions, in the case of a molecular substance, if you have a molecular solute, something that's covalently bonded, like say sugar, when it dissolves in water, it stays as a whole molecule. And since it doesn't break into its ions, there are no ions in a molecular compound, then we call that a non-electrolyte. It will not conduct electricity. And so we have electrolytes, weak, which can be strong or weak. So strong electrolytes means it completely ionizes and is made of an ionic compound. A weak electrolyte is something that partially ionizes, and then you have your non-electrolyte solution. Now, solutions also have some properties that are dependent on how concentrated the solution is. And this is what we call a colligative property. A colligative property depends on the number of particles that are present. In this case, it's a number of solute particles. And so we're going to talk about 4 different colligative properties here. The first is vapor pressure. Now, when you have a solution and it is very concentrated, those ions or solute particles are floating around, and it's kind of there's an attraction there that's being held with the solvent and the solute. And that attraction keeps the solvent in place. And so whenever those solvent molecules are moving around, some of them may have a tendency to escape into the vapor phase. And so as they're escaping, they have a vapor pressure. Now, if there's lots of solute molecules present, it's going to kind of keep those solvent molecules in place. And so there very few is going to end up leaving the solution and go into the vapor. And so therefore, the more concentrated the solution is, the more solute there is, the lower your vapor pressure can be. So whenever a concentrated solution, or as you add more solute to a solution, the vapor pressure will decrease. It's a lowered vapor pressure. And so this is why it's called a colligative property, because it depends on the number of solute particles there are. Another property that plays a role in the number of particles is boiling point. Now remember, what is boiling point? Boiling point occurs whenever the vapor pressure equals the atmospheric pressure. When the vapor pressure equals the atmospheric pressure, then we have an equal number of particles escaping as is leaving, and boiling happen. Now, to get to that vapor pressure, we have to add more heat to the solution. So more heat means that we have to elevate the temperature of that solution to get boiling to happen. So to get to a boiling point, we have to have an increase in vapor pressure. Remember, as we add more solute, the vapor pressure is going to decrease. So we have to add more heat to get that vapor pressure up. So therefore, the boiling point is elevated. The boiling point increases as we increase the concentration of something, of a solution. So as we adding more solute to something, the vapor pressure will decrease. And so since the vapor pressure decreases, the boiling point has to increase. And so we have a boiling point elevation that happens. Now let's go to the other spectrum, and that is freezing point. What happens when what is freezing? Freezing is when we're going from the liquid phase to the solid phase. And so for that to happen, the liquid molecules have to slow down and orient itself into some type of solid. Now, we previously talked about the different types of solids, whether it's a molecular solid, a covalently networked solid, And so an amorphous solid or whatever. But in all those cases, a solid is where the atoms are in a particular location, particular spot, and they kind of stay there. And so the temperature's got to decrease, the kinetic energy decreases where the molecules end up staying where they are. Now, if there is solute particles mixed in there with the solvent, then those solvent molecules can't really get to where they really need to be. And so energy still has to escape. And so as you increase the solute particles, the freezing point will end up going lower and lower. And so we have what we call a freezing point depression that happens as you're adding solute to a solvent. Now, the last property, colligative property we're going to talk about is osmotic pressure. And whenever we have more solute, we have a lowered osmotic pressure. And so before we talk about what osmotic pressure is, we need to talk about osmosis. Osmosis is simply the movement of solvent to equalize concentration. And this is very common in biology. Your cells use osmosis all the time to balance out the electrolytes and balance out concentration. So if we have a cell that has a certain salt concentration, and then outside of the cell is a different concentration. Well, the water molecules will move through the cell membrane to equalize those concentrations. And that is what osmosis is. Osmosis is the movement of solvent particles across a semi-permeable membrane. Solute particles don't move, it's a solvent that moves. In this case, it's water. And so if the osmotic pressure, which is that pressure of movement of solvent molecules, will actually lower as we increase this amount of solute particles. And so we end up with the 4 colligative properties that are dependent on number of particles, and that is a lowered vapor pressure, an elevation of boiling point, a lowered freezing point, so a freezing point depression, and also a lowered osmotic pressure.